Here I'm providing some instruction for assignment number 100. Wir Bauen Auf. These circles represent orbitals. Arrows will represent individual electrons with a spin up or spin down. Always go to lowest energy is the key, and these are arranged on the page so that lowest energy is down here and highest energy is up top. So that's the way they are arranged on the page. That means that when I actually place my electrons in these orbitals, I will start here. This is the lowest energy possible, and that's a spin up electron. I'm trying to place 9 total, so my second electron will also join in the 1s orbital. My third electron has to choose here in the 2s 2p. 2s is lower. Notice how it's lower than 2p. So the third electron goes here. Fourth electron will join it. Now I have 3 orbitals here. 3 orbitals right here that are all the same. When you have orbitals of the same energy, electrons will spread out. So there's electron number 5, there's electron number 6, there's electron number 7. So common error is for people to double up on these orbitals when they shouldn't. Spread them out if they're even in energy. See how these are even in energy? Spread them out. Okay, but I still have to put 2 more electrons. This is now when I do double up. There's 8, there's 9. That is the electron configuration for fluorine. I'll erase my extra marks here, and that's what it should look like right there. Here's B, which is silicon. 14 electrons. Try this one yourself before you watch my answer. Alright, 14 electrons, lowest energy is down here at the bottom. So that's where I'll start. Here's electron number 1, here's electron number 2. 3 will go here because 2s is lower than 2p. So 3 is here, as is 4. 5, 6, and 7 spread out. 8, 9, and 10 double up. 11, 12. So always lowest energy, lowest energy. But now I have 3 that are the same energy. And in that case, I'll do 13 and 14, and I'll have an empty orbital here. And that's the electron configuration for silicon with 14 electrons. Now, once I have drawn the picture here, I am going to summarize the picture with a string of letters and numbers. I start at the bottom here with 1s. I say there are 2 electrons living there, 1s2. Here's the next one. It's the 2s orbital. 2 electrons are living there. 2p I can lump all together. How many total electrons? 6. 3s is next. Here's 3s, just going up the line. 3s2 and 3p is where I end with 2 electrons. So this is the shorthand that describes the picture. It's called the electron configuration of that atom. Alright, now I'm on 2. This one says write out the shorthand electron configuration, so that's the string of letters and numbers. Use this set of orbitals to help you figure it out. So for example, calcium is 20 electrons. Calcium is 20 electrons. The first 2 are going to go here, and you can imagine them being 1 up, 1 down. And the next 2 are going to go here in the 2s, and so on and so forth until you get to 20 electrons. I'll just show you how each one of these ends. I leave it up to you to figure out whether you can match my designation. So calcium will end with 4s2. Nickel will end with 3D8. And rubidium, I'll just leave that up to you. I won't give you an answer for that one. You can show me when you bring your homework in. Number 3, you need to understand these words here, alone in an orbital. So if I have two electrons that are sharing, those are called paired electrons. But if I have a single electron, it's all alone, that's an unpaired. So if you can draw the picture, the number of unpaired electrons in each element will be easy to see. Like if this was my picture here, I have one unpaired electron. So some answers to help you. Calcium, you should find 0. So try to figure out why is it 0. Nickel is greater than 0, but less than 4. So you can try to figure out what's the actual answer. It's not 0, it's not 4, it's somewhere in between. And this one I won't give you any hint, I'll just say figure it out.